All right, graphs of exponential functions. A basic exponential function is in the form of f of x equals a to the power of x, where a is any positive number except 1. Okay, so I wrote that right here. A is anything except 1. The graph comes in two shapes depending whether a is between 0 and 1 or a is greater than 1. Figure 9.2 is the graph of f of x equals 1/2 to the x, and 9.3 is f of x equals 2 to the x. Let's take a look. Okay, so this is basically what a graph looks like when the value of a is between 0 and 1. So in this case, this is 1/2 to the power of x. And if you kept multiplying 1/2 over and over again, that fraction is going to get smaller and smaller. So as the exponent x, as x gets larger, the overall value of y decreases. It gets smaller because you keep multiplying 1/2 over and over. So the graph trends downward as x gets larger, okay? And it's going to approach y equals 0 but never reach it. Okay, and the opposite is true when a is greater than 1. For instance, if you take the number 2 and you raise that to the power of x, as x, the exponent, gets larger and larger, the 2 gets multiplied over and over again, and the overall value of y is going to increase. All right, so if a is between 0 and 1, it's going to decrease, and if a is greater than 1, it's going to increase for the exponential function. So in general, to sketch the graph of f of x equals a to the x, you can just try x equals -3, 2, 1, and 0, and positive 1, 2, 3. Okay, so we're going to try those points on a few graphs. And you want to remember your negative exponents, okay? If you have a to the negative n, that's the same as a to the negative n over 1. Okay, if you take this entire numerator and move it to the denominator, you just change the plus minus sign on the exponent. So a to the negative n equals 1 over a to the n. All right, and again, if you have a negative exponent applied to a fraction, you can take the reciprocal of that fraction and change the plus minus sign on the exponent. So 1 over a becomes a over 1, and the negative n becomes positive n. And of course, a over 1 is just a. All right, so I'm going to get to the graph paper. We're going to sketch the graph f of x equals 2.5 to the power of x. This is y equals. So let's go to the graph paper. All right, x values, we're going to do -3, -2, -1, 0, and then 1, 2, 3. Truth of the matter is, you probably don't even need all of those. Okay, but in each case, the x is going to be the exponent of 2.5. Okay, so you're going to need a calculator. All right, so in this case, it's going to be 2.5 to the -3, and 2.5 to the -2, 2.5 to the -1, and of course we know 2.5 to the 0 because it's to the power of 0. That's just going to be 1. All right, and at 2.5 to the 1, that's just going to be 2.5. All right, and then we're going to do 2.5 squared and 2.5 to the 3rd. Okay, so I need to do some calculator work here. Just for your information, the fastest way to do this, do 2.5 squared, and I get 6.25. And then on 2.5 squared, take the reciprocal of that, and you'll have 2.5 to the -2. All right, so that's the fastest way to get these values. So if I do 2.5 to the 3rd, I get 15.6. I'm going to round off because there's no reason to have so many decimals. And then I'm going to take the reciprocal of that answer, and I get 0.064. Okay, again, I just rounded off. And here, 2.5, take the reciprocal, and I get 0.4. All right, so these are going to be all the values for the y coordinates. All right, so let's go to the graph. At -3, it's almost y equals 0. So at x equals -3, I'm just going to put it on the x-axis. At -2, it's 0.16, so it's maybe a tiny bit higher. At -1, it's 0.4, that's approximately a half. At 0, it's 1. At 1, it's 2.5. At 2, it's 6.25, so 2, we're going to go up to 6.25. Okay, and at 3, it's already way off the graph. Okay, so the 3 is already way up here. And we're just going to draw the graph. Okay, and we know that it approaches y equals 0, but never reaches it or goes below it. Okay, it's too difficult for me to draw it exactly, and the 3 was like way up here, so this just keeps going. All right, but that makes sense because this is greater than 1. So if you raise that to an exponent, as the exponent increases, the y value overall function is also going to increase. All right, and in the book, they basically got the same thing I did. All right, let's try g of x equals 1/3 to the power of x. Let's go to the graph paper. All right, so same setup as before. So x is -3, that's going to be exponent on 1/3. Okay, so that's going to be 1/3 to the -3. And let's see if I have enough room. This is going to be 1/3 to the -2. This is going to be 1/3 to the -1. -1 just does the reciprocal. So the reciprocal of 1/3 is just 3. Okay, and of course 1/3 to the power of 0 is just going to be 1. All right, 1/3 to the power of 1 is just going to be 1/3. All right, if you want to round off, it's 0.3. And let's see, 1/3 squared. And 1/3 to the 3rd. Believe it or not, many of these you can do in your head. Okay? Because the negative sign takes the reciprocal. So 1/3 with a negative sign, the reciprocal of 1/3 is 3. So that's going to be 3 squared, or just 9. Okay? And 1/3 to the -2 is the reciprocal of 1/3 squared. So this 9 is down here. That's going to be 1/9. Okay, rounding off, that's about 0.1. And 1/3 to the -3, take the reciprocal. That's going to be 3 to the 3rd, which is 27. And 1/3 to the -3 is the reciprocal of 1/3 to the 3rd. So this is going to be 1/27. Okay, and let's see, 1/27 is going to be close to 0. Let me see here. All right, I just get 0.04. All right, anyhow, -3. Maybe we need to change the scale of this graph a little bit. Okay, how about we multiply all of these numbers times 3 for the y-axis? So I'm going to do that. All right, I multiplied each number by 3. I changed the scale. I did not do it down here in the negatives because y is not going to be negative. So at x equals -3, x-axis, go to -3, and y equals 27. That's off the chart, so that's about right there. Okay, at -2, it's 9. So at -2, I'm going to go to 9. At -1, it's 3. At 0, it's actually 1. So that's going to be a third of the way between 0 and 3. And of course, it keeps getting smaller, 0.3, 0.1, 0.04. Okay, so by the time it's at 3, it's 0.04. By the time it's at x equals 3, it's almost touching the x-axis. All right, so there you go. And it approaches the x-axis, which is y equals 0, but technically never reaches it. All right, so that's basically it. Now, the one in the book, since I changed the scale of this, the one in the book is probably going to be a little bit steeper than mine, but that is the basic idea. Because this value of a is in between 0 and 1, since it's a fraction, you increase the exponent and it gets smaller and smaller, approaching y equals 0, but never reaches it. All right, so here's what they got in the book. This is 1/3 to the x. Like I said, their graph is a little steeper than mine. I think it is anyway. Looks like they almost had to do the same thing. See how they changed the scale of the y-axis versus the x-axis. The x-axis counts by 1s, but their y-axis counts by 4s.